Imagine this for a second. You've spent a full decade, 10 long, exhausting years, pouring every ounce of effort, money, and pride your country can muster into building a passenger plane. A machine meant to soar through the skies and prove your nation's strength to the rest of the world. You've reverse-engineered engines, picked through the remains of crashed airliners, and worked day and night to piece together something extraordinary. And then, when it's finally done, your own government takes one look and says, "Yeah, it's good, but we don't want it." This is the story of China's Y-10, a plane that was much more than a copy of a Boeing 707. It was a symbol of national resilience and ambition, built not just to transport people, but to prove that a country shut off from the world could take on one of the most difficult engineering challenges of the time. And to really understand why anyone would try to build such a thing, you need to rewind back to 1970s China. Now remember, this wasn't the China we know today, with bullet trains, smartphones, and a booming economy. This was a nation still recovering from the chaos of the Cultural Revolution. At that point, the country was largely cut off from the world, especially the West, both politically and economically. Every decision had to align with the belief in self-reliance. And importing passenger jets from Boeing or Douglas wasn't just ridiculously expensive, it went against the entire philosophy of the government. So in August 1970, they greenlit something called Project 708. This would later become the Y-10, and it wasn't just about building a plane. It was about building confidence, industry, and showing the world, and themselves, what they were capable of. Leading this bold mission was the Shanghai Aircraft Manufacturing Factory, with a man named Ma Fangshan in charge of the technical side. And here's where it gets interesting, because this wasn't just a plane project, it was a national statement. Every bolt, every wing, every instrument panel had to say, "We can do what the West can do." But there was a problem, a huge one. The Cultural Revolution had devastated China's technology and education sectors. Many of the country's best engineers and scientists had been sent to labor camps. Libraries were bare. Access to technical journals was nearly non-existent. So how do you build a sophisticated jetliner when you don't even have basic engineering resources? Well, through sheer grit. The Y-10's engineering team worked in freezing, dimly lit buildings, using ancient tools, scribbling calculations by hand, and relying on scraps of information, sometimes literally pieced together from wherever they could find it. Stories from that time describe engineers working 18-hour days just to calculate how the weight of the plane would be balanced, something their American counterparts were handling easily with computers. One engineer put it perfectly. It was like learning to fly while building the plane at the same time. And yet they refused to quit. When materials weren't available, they improvised. When tools broke, they made new ones from whatever they had lying around. And if no one knew the rules for how something should be done, they invented their own. It took 5 grueling years just to finalize the plane's designs. And when they finally started construction in 1975, a whole new set of problems showed up. For example, aluminum sheets. Boeing was using high-quality aluminum sheets about 2 meters long to build their planes. In China, the factories could only produce sheets 8 meters long. That might sound like a weird problem, but it meant Chinese engineers had to rethink how the entire structure was assembled. And it wasn't just the metal. One of the biggest challenges was the engines. See, jet engines are some of the most complicated machines humanity's ever built. And China at the time didn't have access to one they could study in detail. That is, until 1971, when fate handed them an opportunity. A Boeing 707 from Pakistan International Airlines crashed while landing in China. Rather than treating it as just a tragedy, Chinese engineers saw it as a rare chance to learn. They carefully examined the wreckage, especially the JT-3D engines, which powered the 707, studying every part they could get their hands on. This wasn't some rogue operation either. It was a planned, state-supported effort to soak up whatever knowledge they could from any available source. The result of this scavenger-style R&D was the WS-8 engine, China's attempt to replicate the JT-3D. Unfortunately, it didn't work out. The WS-8 had constant oil leaks, weak performance, and reliability issues that made it unsuitable for actual flight. As relations between China and the US warmed up in the late 1970s, the government quietly abandoned the WS-8 and began importing real JT-3D7 engines from the US. But while they gave up on the engines, they kept pushing forward with the rest of the plane. At first, the engineers tried to copy the 707's wing design by studying photos, which, shocker, didn't go so well. So they pivoted to another aircraft they had better access to, the Hawker Siddeley Trident. China had been operating these British-built jets since the early 1970s, which meant they had maintenance manuals, blueprints, and first-hand knowledge about how it was put together. In the end, the Y-10's design became a strange hybrid of different influences, some from the 707, some from the Trident, and a good dose of on-the-fly improvisation. From a distance, the Y-10 looked a lot like a Boeing 707, but up close it was a Frankenstein of necessity, built by a country that had to figure out modern aviation without the modern resources. Now here's where things start to get really interesting. The first Y-10 wasn't even built to fly. It was a ground test model, meant for structural stress tests, system checks, and thousands of hours inside wind tunnels. They needed to see if this patchwork of engineering could even hold together under pressure. And it did. Well enough, at least, that they decided to build a second one. This one destined to leave the runway. On September 26, 1980, history was made. Captain Wang Jinda, a decorated test pilot, climbed into the cockpit of the Y-10, fired up those American-bought JT-3D engines, and took to the skies above China for the very first time. For a nation still healing from decades of internal struggle and international isolation, seeing a home-built passenger jet take flight was a symbol of something bigger than technology. It was a symbol of national pride. Over the next 3 years, the Y-10 made around 130 test flights, visiting cities like Beijing, Harbin, Guangzhou, and Chengdu. In one particularly daring mission, the plane even flew over Mount Everest, a jaw-dropping feat for a country with limited aviation experience at the time. For a while, it genuinely seemed like China had cracked the code, and a new era of homegrown aviation was about to begin. But as you probably guessed, it wasn't all smooth flying. Test pilots began noticing quirks with the Y-10 that made it a tough sell. For starters, it guzzled about 15% more fuel than the Boeing 707, which in the airline business is a deal-breaker. It also had a shorter range and could carry fewer passengers than its Western counterparts. Pilots described it as feeling heavy in the air, particularly when landing in crosswinds. One even said it felt like flying two completely different airplanes bolted together, a pretty telling metaphor for a design stitched together from borrowed parts and desperation. And yet, despite all its flaws, it never crashed. Not once. Every one of those 130 test flights landed safely, which, given the circumstances under which it was built, is nothing short of remarkable. The government even staged a symbolic flight where the Y-10 carried several high-ranking Communist Party officials as though it were a commercial flight. It was a publicity move, meant to show the world and the Chinese people that the country's aviation program was ready for prime time. But behind the scenes, trouble was brewing. By 1981, China's aviation authority officially declined to purchase the Y-10 for its national airline fleet. The official excuse? The country already had enough planes, but the real reasons were a mix of politics and practicality. The timing couldn't have been worse for the Y-10. After Mao Zedong's death in 1976, China began shifting away from the strict, self-reliant policies of the Cultural Revolution. Deng Xiaoping, the country's new leader, was steering China toward modernization, opening up to Western technology, trade, and investment. Projects born under Mao's ideology-driven agenda suddenly looked outdated and politically awkward. The Y-10 was one of them. It was a product of a different era, built to prove a point that no longer aligned with the country's new direction. The government quietly distanced itself from the project. When it was officially cancelled in 1983, there was no ceremony, no speeches, no recognition for the engineers and workers who had spent over a decade fighting to make it happen. The message was unmistakable. The age of ideology-driven mega-projects was over. From now on, practicality would come first. Meanwhile, China was busy cutting deals with Western aerospace companies. In 1982, just a year before the Y-10 was scrapped, the country purchased 10 brand-new Boeing 737s, a clear sign that the future of Chinese commercial aviation would be imported, not homegrown. For those who had worked on the Y-10, it was a bittersweet ending. On paper, it was a total failure. No customers, no commercial flights, no production orders. A decade of work grounded before it ever had a chance to succeed. But if you look a little deeper, it wasn't a total loss. Because what China pulled off was still incredible. At a time when its industrial base was lagging, when experienced engineers had been purged, and when information about modern jetliners was almost impossible to find, the country still managed to build a fully functioning 4-engine passenger plane that flew over 130 times without a single fatal incident. And perhaps more importantly, the project laid the groundwork for the future. Building the Y-10 forced China to develop manufacturing techniques they'd never needed before. They learned how to machine aluminum with aerospace precision, manage quality control for complex systems, and coordinate massive, multi-year, multi-factory supply chains. Even the plane's electronics were a triumph, considering how far behind China's tech sector was at the time. The Y-10's avionics might have been outdated compared to Western planes, but they were good enough to guide a jetliner safely through the sky. And that was a giant leap forward. Those skills didn't disappear when the project was cancelled. They carried over into China's next wave of engineering projects, from satellites to high-speed trains to today's modern jetliners like the Comac C-19. And here's the thing most people don't realize. The Y-10's legacy didn't just live on in aircraft. The knowledge gained from building it spread out across China's growing industrial world. Engineers who cut their teeth on the Y-10 went on to lead projects in space exploration, telecommunications, and high-speed rail. The lessons about supply chains, quality control, and complex project management became part of China's industrial DNA. Today, when you see China's modern airliners like the Comac ARJ-21 and the C-919, you're not just looking at shiny new jets, you're looking at the spiritual successors of the Y-10. Not because they copied its design, but because they inherited its grit, its lessons, its history of problem-solving when the odds seemed impossible. In fact, one of the things that makes this story so fascinating is that it proves something we often forget. Failure isn't the opposite of success. It's part of the process. The Y-10 was a commercial failure, sure, but it was also a national classroom. A proving ground, a bold, ambitious attempt to do something no one believed possible, and in doing so, it taught a generation of engineers and leaders what it takes to build world-class technology. So now, here's where you come in. If you found this story as wild, fascinating, and downright inspiring as I did, smash that like button and hit subscribe, because we dive deep into stories just like this all the time. Forgotten engineering marvels, lost technology, and the untold human stories behind the machines that shaped our world. And hey, drop a comment below. What do you think? If the politics had been different, if China had had 5 more years, could the Y-10 have succeeded? Or was it always doomed by the weight of its own ambition? I'd love to hear your take. Turn on those notifications too, so you don't miss what's coming next. Because trust me, we've got some incredible stories on the way. Until then, thanks for watching, and I'll catch you in the next one. Did you know China once built a secret passenger jet to rival Boeing and Airbus? And no one talks about it. Meet the Shanghai Y-10, China's first large commercial airliner project. A bold, high-stakes attempt to break into the global aviation industry during the Cold War. In this video, we uncover the fascinating story of the Y-10, how it was born out of political ambition, built in isolation, and ultimately abandoned before it could take paying passengers. From copying Boeing 707 parts to reverse engineering engines from a plane crash, this video dives deep into one of aviation history's most overlooked engineering feats. Discover how this failure actually paved the way for China's modern aviation successes, like the Comac C-19, and how the lessons learned from the Y-10 shaped China's space program. high-speed rail network, and industrial powerhouse status today. If you're into forgotten aviation stories, engineering breakthroughs, or legendary aircraft projects that almost changed the world, hit that subscribe button and join us for more deep dives into incredible, untold tech history. Like, comment, and subscribe for more rare aviation stories, engineering marvels, and lost technology deep dives.